Let's do another example of finding the zeros of a polynomial, okay? And I'm going to emphasize here at the very beginning that we are supposed to find the real zeros. Why am I making that distinction? You'll find out in the middle of this problem, okay? So find the real zeros of the polynomial by factoring, okay? You're gifted this piece right here because you don't have to find zeros by factoring. If you want to graph it, you can find those, but factoring is a skill that we need to get much better at. We need to practice this. So we're going to keep practicing by factoring and not graphing this. Okay. You can verify your answers are good by graphing it, but we want to find our zeros by factoring. So let's take this function h. All right. It is a binomial. The first thing we want to look for is hopefully it's obvious to you that there are common factors here that we can factor out. So let's take those out, right? Both of the coefficients are divisible by 2, and both of these terms have, at the very least, x to the first power, so we're going to factor that out. When I factor the 2 away from here, it's gone. When I factor away one of the x's from here, that leaves me with 4 x's, okay? Minus 32 divided by 2 is 16, and when I take this x away, that's gone. Now when we look at this polynomial, the way that it's structured, how do I continue to factor this? Well, 2x is 2x. Let's look at this binomial. It's not blatantly obvious right off the bat, but we have two options, right? When you have a binomial and you're talking about factoring a binomial, you're either looking for the difference of squares or the sum and difference of cubes. And if you look at this and you say, well, that's not squared because it's x to the fourth. Any even power of x, okay, is a perfect square, right? X to the fourth is x squared squared. X to the sixth is x cubed squared, so on and so forth. So any even power is a perfect square, and this is a perfect square. So I can factor this perfect difference of squares, take the square root of x to the fourth. That's x squared and x squared. Take the square root of 16, that's 4 and 4. And because they're conjugates, one gets a minus, one gets a plus. Right? And now you're sitting here and you're just saying, yay, I did it. I factored this. Take a closer look. What is this? This is also the difference of squares, right? So when we look at this problem, this factor can also be factored into conjugates, where we take the square root of x and we take the square root of 4, one with a minus, one with a plus. Now this quadratic factor, okay, this is not the difference of squares, this is the sum of squares. And the sum of squares does not factor like the difference of squares, right? And this is where I'll bring you back to here. At least not when we're talking about real numbers, okay? Emphasis on the word real, okay? And we'll talk about this in a second. So here are my factors, right? I cannot factor this anymore, at least not in the real number plane, okay? Now in terms of finding the zeros, okay, what do we have here? We have 2x, right? We have our linear factors, x minus 2 and x plus 2. We have our quadratic factor, x squared plus 4. We've done a couple of videos so far that said we know what these zeros are, right? The zero that we get from here is the opposite of this number, okay? And that's only because there's no visible coefficient. The zero we get from here is the opposite of that number, which is -2. What zero do we get from this? Well, you can set that equal to 0 and solve, but you're going to get 0, okay? So anytime you see a standalone x term as one of your factors in your polynomial, the 0 that comes from this is actually the number 0. Let's take a quick jaunt over here to look at this factor, right? I can't say that -4 is a factor. I can't jump down like I did here. When I found these zeros, it was because it was x to the first power and there was no visible coefficient. That's the only time we can make that shortcut. This is x squared. So I can't make the shortcut that says, well, it's -4. No, it's not. This is a case where we have to take the factor off to the side and actually solve. And if I did that and I subtracted 4 from both sides, now I'm taking the square root. And if you're thinking about some of the work that we did earlier in this unit with complex numbers, you're like, yeah, I know what the square root of -4 is, right? It's the square root of -1 times the square root of 4, which is I and plus or minus 2, right? So this is what we get for x. True, okay? And we'll get there eventually. But when the problem talks about the real zeros, okay, this is not a real number. So we kind of disregard all of this work and say, those are imaginary zeros. They don't count right now. Now, in terms of the multiplicity of these zeros, do we have any exponents? No, no, no. So for each of these three, these are all odd multiplicity, which means that they cross the x-axis at these points, okay?